Hi everyone. I've created this problem to help you prepare for the gen ed assessment tomorrow. Um, so you could get a sense of what it's going to be like. So it's an article. It's shortened. I've shortened it, but it's an article from Pew Research, and what it says is it says about 8 in 10 women in opposite sex marriages say they took their husband's last name. And so it says marriages in the United States have been changing in many ways over the past several decades, but the tradition of women taking their husband's last name is still going strong. In a new Pew Research Center survey, we asked married people whether they changed their last name after marriage. And so here's the data. Um, and so about 79% of women uh, married to men have taken their husband's last name. And so that's the basic premise. It's at 79% that we need to really look at. And also, the other thing to keep in mind here is it says how we did this. So the Pew Research Center asked 2,437 US adults in opposite sex marriages whether they changed or kept their last name when they got married. And we're assuming those are adult women. And so, all right, so let's go to the questions. It says use the survey results to construct a 95% confident estimate of the percentage of women in opposite sex marriage pick their husband's name. So what we're gonna do is we're gonna go ahead and use the calculator, and we're gonna go to stat, and we're gonna go to test, and we're gonna scroll down to a one prop, a prop Z, one prop Z interval. That's the one that we need. This has to do with proportions, and we're going to use the normal distribution, and we want an interval. So I'm going to press enter. All right, so we're given some things to input. Confidence level is already in there. You see that. It was a 95% confidence level, so 0.95. The X is going to come from the data. So we're going to go back to the problem. Notice that there were 2,437 adults, which we're assuming were all women, and 79% of them said they took their spouse's last name. So I'm going to go ahead and find out what is 79% of 2,437. So let me see if I could share my calculator. So it is 2,437 times 0.79, and the result is 1,925.23. So we'll round off to the 1925 because we're required to have a whole number. So 1,925. So 1,925 goes in that space. And the N is the number of individuals that were surveyed. So back to how many they were, 2,437. So that's what we need. We'll go ahead and calculate it. And what it gives you is it gives you the interval, which I'm gonna write on my paper just to have it. 0.73, 0.77373 and 0.80608. The p-hat is already computed. It's the same 79% from before, using the whole number, and then n. All right, so that's the interval. And let's see if we can answer some of the questions. So I think that answers the confidence interval. So somewhere between 77% and about 81%. And I'm just going to annotate it on the document just to have it. So 0.77, 0.77, I'm going to round off to 4. And 0.806. Okay, this is find the margin of error for the survey, and they give you they give you a hint. So we could use this formula, which is a little more complex, but the easiest way would be just to subtract these two values, and maybe we'll try it both ways. And divide by 2, because that should directly give us the answer. So let's go back to the calculator, because the values are in there anyway, right? So I'm going to take 0.77373 points, whoops. I'm going to do 0.806 subtract 0.774. And if I divide, that's the distance from the endpoints of the interval. And if you divide that by 2, you'll get the margin of error. And just to check, you can take your p-hat, which is a 0.79, and you can subtract 0.016, and that gives you your bottom, the bottom of the interval. And if you take 0.79 and you add 0.806, no, my bad, you take 0.79. Let me do that like one more time, sorry. 0.016, then you end up with the top of the interval. So the margin of error is 0.016. So let's go back to the document. And now, according to the poll, the margin of error is 2.3 percentage points. So based on the numbers used, based on the numbers given, the margin of error that we computed is lower than the margin of error stated in the methodology. So you just want to say something to that effect. I'm not sure that we need to necessarily make a judgment as to why it's different. I don't know that we have enough information given in the problem to go any further. Okay, so now it says, and I'm going to clear it because there's some overlap there. It says explain why or why not an online news website would be justified in publishing this claim. More than 75% of American women in opposite-sex marriages will take their husband's last name. So based on that interval, which I'm going to write it down again, the interval was 0.774 and 0.806. Then notice, so the way you interpret this is that there's a 95% chance, or better stated, we are 95% confident. That's the way you would state it. We're 95% confident that the interval contains the true population proportion. And I can write that down. We have space over here. We are 95% confident that the interval contains the true population proportion. Therefore, the conclusion that, what is it, more than 75% of women take their husband's last name. I am running out of space. Is justified. Okay. So finally, the last question said, what are some factors when deciding to take their husband's last name or not? And how can those be used in the survey to get more specific data? So it might be worth exploring further someone's ethnicity. It might be worth exploring someone's religion. It might be worth exploring someone's economic status. So all those are possible things that a statistician might consider in order to understand whether there are other factors, or what are the factors going into someone deciding to keep their husband's last name. when getting married. Anyway, hopefully this helps a little bit. Um, and you could see the process of actually just getting the confidence interval with a calculator, how you get the margin of error, how to make a comparison, and then how to look at a claim, and then how to think further about what the data actually means. Okay, good luck with tomorrow's problem.